Good morning, dear children. This is second video of chapter number 11 of physics. The name of the chapter is Human Eye and Colorful World. The first topic in this video is rainbow formation. This is the natural and practical application of refraction of light. A rainbow is a natural spectrum appearing in the sky after a rain shower. And why it is caused? It is caused by the dispersion of sunlight by water droplets. If you remember about dispersion, we have done in our previous video. Dispersion is the splitting of white light into 7 constituent colors. And where are these water droplets present? They are present in the atmosphere. These water droplets, they act like small prisms. They hang in the air and then they act like small prisms. And what do? They refract light and disperse the sunlight. So first of all, refraction occurs and dispersion occurs, and then the light is reflected internally, and finally it is refracted again when it is coming out of the raindrop. So due to dispersion of sunlight and internal reflection by the water droplets, we can see rainbow colors. So let us understand it once again. Here you can see a ray of sunlight is coming, and then we have refraction of light and dispersion of light. Refraction means bending of light and dispersion means splitting of light into 7 colors. And as you can see, internal reflection occurs, and after internal reflection light bounces back, and then after refraction, after again bending, it comes out, and that is how we are able to see rainbow colors. And this is another diagram showing rainbow colors, rainbow formation with the help of water drop hanging in the air after the rain. Now our next topic is atmospheric refraction. As it is clear from the word atmospheric refraction, here refraction is done in atmosphere, and atmosphere has different layers of air, and all the layers of air, they do not have equal densities. Some layers are more dense and some are less dense. And if you can understand, the air which is closer to the surface of earth, it is more dense, and the air which is away from the surface of earth, it is less dense. As we go up high on the mountains, the density of air goes on decreasing. So atmospheric refraction, it is due to the gradual change in the refractive index of the atmosphere. The refractive index of atmosphere gradually increases towards the surface of earth. It means as we come down, the refractive index, that will go on increasing, because the hot air above, it is less dense than the cool air. So light gradually bends towards the normal. So this is very important. You can see here in the diagram, this is a ray of light and it is bending. This ray of light is coming from the star. In place of going straight, it is bent and then it enters the eye of observer. And if you produce it in the backward direction, then this reaches another point where we see apparent position of the star. So in the diagram you can see clearly that apparent position of the star, it is above the real position. So really the star is lower, and whatever you are watching, this is actually the apparent position of the star. So actually star is having lower position. Then we have next topic, twinkling of stars. The twinkling of stars is due to atmospheric refraction of starlight and due to the changing position of star. The star, they keep on changing their position. They appear to twinkle because of the movement of the layers of the atmosphere. So the light from the star, sometimes it appears brighter and sometimes it appears fainter. So that is why the stars appear to twinkle. So due to atmospheric refraction, the light coming from the star, it becomes brighter or fainter, and that's how the stars, they appear to twinkle. Now planets, they do not twinkle. Why planets do not twinkle? We have answer here. Planets are closer to the earth than stars. The light from stars, that is considered to coming from a point source of light. Now what does it mean? It means stars are very small in size, so they act as the point source of light, very small source of light. But the light from the planet, that is considered as the extended source of light. So the light from the planet, it nullifies the twinkling effect. It means overall brightness of the starlight, not starlight, it is actually planet light. Overall brightness of the light coming from the planets, that remains more or less same. So twinkling effect is not seen. So here we can see again the twinkling of the stars, the Earth's atmosphere, that is shown here with moving pockets of cold and warm air. Since the cold and warm air that keeps on moving, so starlight, it appears dim or it appears brighter. So that's how the stars, they appear to twinkle. That's it in this video. Good luck.